Yet another of these PowerProg plug-in drive OBD2 performance chip tuning boxes to take a look at. And this one came from a Chinese seller, but with a UK warehouse, I presume. Million billion. And this one cost £3.89. And the reason I bought this specific one is because they actually show a picture of the circuit board in the listing. I'm not sure whether that's a good thing. It certainly made me buy it, though, because I thought the circuit board was very interesting. So let's take a look at the unit first. I should say I have tried this. I plugged it into my mum's old Skoda and it did nothing. And I know why it did nothing. It's because it does monitor the canbus, but that's the only network it monitors. And my mum's old Skoda monitored, where's the little chart here? It monitors the ISO 9141 K line and L line. That's the only network activity I've been able to detect on that vehicle. So, do I even bother reading the instructions? It does. It goes through the sort of, it tries to make it plausible again by saying that when you plug it in, you should pull the car key from the ignition, find the OBD2 connector, and it's got a little guide to that in the back of this. It's a connector on your vehicle for connecting diagnostic units. Plug the unit in, insert the key to the ignition and twist to the first position, but do not start the engine. Press the reset button for about 5 seconds. After releasing the button, just wait for a while, about 30 to 54 seconds, that's a bit vague. It will communicate and establish connection with ECU. Okay, start up the engine, and then from that point it's learning your characteristics over the next 200 kilometers, by which time you'll have forgot you even bought the thing. So let's open this up and show you what's inside. A nice feature about this, it's got the reset button on the top. That does actually make a huge difference. The other ones they're very lazy. They've got a hole drilled that you have to poke something through and fumble about in the circuit board for the reset button. Not that any of them are actually going to be doing much. So here's the spudger. Let's get down a bit here. Here's the spudger, and it's a very simple circuit board. It's got one little 8-pin chip. Isn't that amazing? It knows the characteristics of every single engine in existence. That's amazing. Since 1996, no less. It's amazing what they can cram in a chip these days, particularly when it's going to be learning your driving characteristics and programming the processor. So let's power this up. Let's get the bench power supply on. Let's hook the 12 volts to the plus rail pin. We'll hook the negative to either of the negative pins. There's 2 negative pins in the canbus, the OBD2 connector. One is for chassis ground and one is for data ground. And if I power this up now, it does its little self-test. It lights the LEDs. And then, which is quite a nice change of this one, it goes into little standby mode and the quiescent current is just 9 milliamps. And if I push the reset button, all it will do is it will reset it and just go through that sort of initialization mode. However, if I then emulate, because there are 2 connections to the canbus network on this, if I was to use this resistor box set to 10k to match the fact they've got 10k resistors down here and get a rough half voltage, it's going to limit the current, and yeah, it's to protect the chip more than anything else. Not that it deserves to be protected. And if I go from the positive to either, if I go to that one, you'll see that the green light lights to show it's detected activity. Oh, it did even better that time. It's gone into full programming mode. I'll reset it and show that again. But basically speaking, as soon as it detects activity on the canbus, if it's in sleep mode, this little blinking light is, if it's very brief, it will just wake up briefly. It will show there's activity. The green light does genuinely indicate activity in the canbus. But if it's held there for a while or jittered on and off, the power light will light to show it's active, and then it will start seemingly to communicate. And the green light would still be then responding to whatever was happening on the vehicle, but it's not anything to do with this. It is seemingly just reading what's happening in that port. And if you take the connections away, it will still continue with its little communicating. And although it looks like it's blinking on and off quite slowly, it's just the sort of, it's the interaction, the frequency of the camera. It's actually shimmering at a very high speed. And anyway, after about a minute, it will cut back off. So let's take a closer look at this. And it will go back into standby mode. That is a refreshing change. Oh, I should have actually measured the current. Hold on. Let's boot this up again. All LEDs lit, 42 milliamps. Let's see what it is once it's actually running. The quiescent current of the processor is that 9 milliamps, which is reasonable enough. Let's wake this up and put it into its little show mode. About 37 milliamps when it's running and about 9 milliamps when it's not. That's not going to drain the battery as much as some of the others did. So let's bring in the circuit board that I've scaled up. I've zoomed up on this. I've taken a nice sharp picture. Let's focus down onto this. So what we have here, we've got the 3 LEDs at the end. We've got this little 8-bit microcontroller. It's one of the anonymous 8-bit microcontrollers. And the only pins of the OBD network that are connected are this one for anchoring, this one for the positive, this one for, let's see, what is that going to be? That's going to be, the positive one is next to canbus low. Let's just make a note of that. I'm just going to scribble on that. Where's a notepad? So the one next to 12 volt is canbus low, and this will be canbus high. And then we've got the 2 ground pins, the chassis ground and the signal ground. So we'll just say ground. They're just connecting both, and they are both common onto the common copper layer here. Unusually for these, quite often these units will have a 10k resistor between the chip and the canbus network so that they can actually monitor what's happening on it, and it provides some protection. Except in the case of, well, this one, it usually just has a 10k resistor between them because it's not affecting the canbus port. Technically speaking, depending on what this chip is, it could theoretically jiggle that port. It's very convincing in that regard. More about the chip later because it's got a very odd pinout that I don't recognise. It's not an AT-Tiny, it's not a PIC microcontroller, I don't think it's a Padauk. I really don't know what this chip is. But what normally happens is they have a 10k resistor, 103, 10 and 3 zeros, between the canbus port and the chip. In the case of one of the other units, Dave at EEV blog spotted something I completely missed, and that was that the pads it was going to on the little chip had a screen print pad underneath the pads, so the pads weren't even soldered on, they were just for show. And the only reason I can think of doing that is they didn't want the risk that if the processor crashed or anything, or some put in the wrong value resistor, it could somehow interfere with the network in a car. Because this can, if something went wrong with this, it can, if this chip failed, it can drag your canbus to an unknown state, and that could potentially stop your car working. It could actually have, you'd be getting error messages left, right and centre, the engine light would come on. It means that everything on that network would not be able to communicate. That's something worth mentioning. The fix for that is to pull the unit out if that happens when you plug it in. And then most of the faults should clear. Some of them may require a while to clear. A few stops and starts of the vehicle over time. The circuitry is such, the positive pin from the OBD port comes to D1. This is just a polarity protection diode. Goes through the polarity protection diode to a 78MO5. That's a 5 volt regulator rated for about 500 milliamps. And this also adds a bit of credibility because it's capable of supplying a decent current, because it takes a bit of current to sway the canbus. It's got a very low impedance. The canbus is just 2 wires, and they've got a 120 ohm termination resistor each end to basically make them less susceptible to interference or signal reflections along the line. And that means you've basically got a 60 ohms across the output, and it actually takes a bit of current to actually pull that up to the opposite state. The output from the 5 volt regulator comes from this pin. It then goes through these switches just have a little metal strip going all the way through, so they're effectively just links through. The reason for that is it's easier to manufacture in that way. It gives them the 4 stable legs, and it also means that on matrices of switches you can actually use it as links to jump other tracks. So we've got a little capacitor here which is connected between 5 volts and the 0 volt rail here, which is connected to the 2 ground connections. It jumps through that, it goes to the microcontroller, and the other side of that goes straight to a pin in the microcontroller, the reset button. What you can't see on this, and this sort of threw me a bit at first, it's like, why did they do this? What you can't see is the fact that these LEDs also have a little resistor associated with them, but they've mounted on the other side of the circuit board. If I look at the other side, the only components I can spot looking down this from the edge are just 3 tiny little resistors in exact same location, pretty much underneath these LEDs. That's strange, because they're the same size of resistors as these. They're actually about 200 ohms, but they could have mounted one of them here, and they could have mounted 2 of them here, and then they wouldn't have needed the double-sided board. That would have been connected straight onto the ground plane. This would have been connected straight onto the ground plane, and these could have gone straight like that. I don't know why they didn't just put the resistors on top, because that's made the circuit board more complicated. It's turned it from a single-sided board into a double-sided board. Other than the fact they do actually have one link going from this LED. Again, unless there's something special about these 2 pins, if this does have some canbus ability, they could have just defined these pins probably as inputs or outputs. It's a very strange design. It's got a few quirks. Let's reverse engineer. Let's actually draw the schematic. So let's make sure I'm well focused down. I think I am focused down on that. We start off with the network coming in, the OBD port. So we've got the plus 12 volts from that, and we've got the chassis, and we've got the data ground. So that's the negative rail, and that's the plus 12 volts. So the plus 12 volts comes in, and it goes straight via a diode actually to the 78M05 voltage regulator that converts it down to 5 volts. That has a reference to the negative rail, and the output then has a capacitor across it, little dinky capacitor. That's this tiny little capacitor here, or in the big drawing it's this capacitor here. It's the only capacitor on this board. But that's just across the output to provide stability to the processor. Here is the CPU. Well, I shouldn't call it CPU, I should call it MPU, microcontroller, actually MCU, microcontroller unit. Let's call it MCU, but it's a mystery MCU. So that gets its 5 volts coming in, and it also gets the 0 volts coming in, the ground reference. We've got 2 resistors, 10K, 10K, 10K. And they go to inputs to the processor, but they also have pins marked can high and can low. And they're used to monitor for activity. The switch is connected between the positive rail. That's just a reset switch, and it goes straight to the chip. So the chip obviously has an internal pull down resistor, so when you push that button it pulls it up and resets it. And other than that, we've got the outputs going to 3 LEDs, 1, 2, 3, with resistors, which I measured at 200 ohms. And they are just they're the light show basically. They're the bit that sort of makes it look like it's doing stuff. So 3 little LEDs. I think that's more or less it, isn't it? Now here's the interesting about the chip. Mystery chip. Let's draw the mystery chip. Little marker to indicate pin 1. So that's 1, 2, 3, 4, 5, 6, 7 and 8. The pinout is such that if I probe this out now with a meter, let's bring a meter in, it's set to continuity. I can already see from the tracks here that 2 of the LEDs are connected to pins 8 and 7. So I'll mark these as LED. So that's an output, LED, LED. Pins 6 and 5 are connected to the canbus pins. So where is the module? So I can actually probe this. I was going to probe the drawing there again. So this one is canbus low, and it's connected So can low, low. That might just be a standard logic input. It might not be a CAN bus driver at all. It's just speculation here. And that's can high. I reckon they're probably just digital inputs, but without knowing what this is. Here's the weird bit though. It's the pinout is very, very strange. I'm just going to untangle my leads here. The 0 volt, the ground for the processor, is this pin. So this is 0 volt. The reset pin is, just double checking here. This is reset. The 5 volts, if I go from the output from the regulator onto these pins here, this is 5 volts. And this is a really odd power pin arrangement. And then finally, skipping under the circuit board, is one more track which goes to that LED. So that is LED again. So reset 5 volt, 0 volt, and I'm guessing just 5 general purpose I/O pins. I don't recognise that pin out at all. Maybe some of you will recognise that pin out. So while I'm here, I should double check. I want to check, where are those 200 ohm resistors? Let's zoom back out again. So I reckon they were connected to the 0 volt rail. Yeah, 200 ohm resistors connected from each of those LEDs to the 0 volt rail. Just as shown down here, I should draw that on. 200 ohms. 3 times 200 ohms, which is a reasonable enough value of resistor. And that is what we've got. So it is just a light show. It's very unlikely it's doing anything other. It is just the one edge it's got over the other units is it is actually monitoring the CAN bus and actually looking for activity before it puts on its light show. And that means it does go into a sleep mode. I'm not sure if it's got a contingency plan for the CAN bus not being connected. Well, it hasn't. I plugged it into the car and there was no, it showed no CAN bus activity. I monitored using an OBD breakout box that lets you plug into the OBD port and the output, and it just lets you see activity on the LEDs, and it lets you actually plug in to actually probe onto the networks. But there was nothing, I didn't expect anything, because I know from using that unit that the only activity I'd seen in the Skoda was the K&L bus. But that's strange. It's quite a neat little unit. They really have, if it's what I think it is, which is just completely fake, it's nice that they've crushed it down into that little 8-pin chip. The one thing they could have done to save a bit more money to make it even cheaper is lift those resistors onto the top here. There's plenty of room for them. And I'm a bit concerned about the fact that the CAN bus on your car is being connected directly to pins on this microcontroller. It does have the facility if something goes wrong that it can actually jam the network on your car. This big black blob, I don't know why there's a big black blob in there. I guess it's marked to show that somebody's checked it or something. Quality control. So there we have it. It's most likely another fake. Well, it almost, you certainly can't cram that sort of information. It is ultimately just a light show, and from showing that it does the wee sort of I'm busy communicating thing even when it's not plugged into a car, I think we can safely say it is just an utter fake like all the others. And the only way you're going to get a performance boost is the psychological one of having this plugged in, seeing that every time the car's running the lights are flickering away inside, and it just makes you feel good, and you manage to convince yourself after a bit of driving that the car is actually getting better. The same way the magnets work, the fuel magnets and other gadgets. And the hold on, I've got another gadget which I've covered before, and the energy Neo socket that you plug into your car cigarette lighter socket, and the LED lights up, and it saves on gas and it saves the earth apparently, and makes you feel all smug and warm inside. So if you see, there are genuine OBD based, or to actually, for most vehicles, if you want your vehicle retuned, if you want your the engine characteristics remapped, there are companies that can do that, but it's a very, very geeky thing. It's a bit complex. It's very expensive. It doesn't cost a few quid from eBay. But by all means, if you want the fun of plugging something into your OBD port, this is one I was going to say recommend it. This one has pros and cons. It's got the nice button, accessible button there. This one has the quite significant con of actually being able to jam your bus if something goes wrong, but on the other hand, it is the simplest of them all, and it does cut down into when there's no activity on the bus. If the bus is sitting in a neutral position, I think, it should hopefully go into sleep mode and draw a lot less current. But this is, as far as Quack products go, I think this is one of the nicer engineered ones. It's quite smart. They've reduced it down to this number of pins. I suppose maybe what they could have done is use analog inputs, and they could actually have monitored the other networks, which usually operate at 5 volts, by just putting a 10k resistor to each network and not sharing and looking for any undulation. Whichever network was active would cause that voltage fluctuation, but I don't think they're going to be that high tech. They're just looking to keep it as cheap and simple as possible. So amusing, but it ain't going to turbo boost your car.